Welcome back to QHSE Talks. Imagine standing in the center of a massive, completely windowless manufacturing floor.
Okay, setting the scene. I like it.
Right, so you're standing there, and suddenly the shrill scream of a fire alarm just cuts right through the heavy hum of the machinery.
Just instant adrenaline.
Exactly. And within seconds, this thick, acrid black smoke starts pooling at the ceiling, and it's banking down rapidly toward the floor.
That happens so much faster than people realize.
It really does. So the overhead lights flicker and die, and they're instantly replaced by those harsh, disorienting strobes from the emergency backup system.
Total sensory overload.
Total overload. You have maybe, 10, 15 seconds to find a fire extinguisher or the primary exit route before the smoke inhalation just drops you to your knees.
Yeah, you really don't have time to think.
So you look around wildly, and the walls and pillars are plastered with just a sea of signage. I mean, red signs, yellow ones, blue ones, green ones.
It's just a wall of color at that point.
Right. Some have these geometric pictures. Others feature, dense, blocky paragraphs of text. In that moment of absolute blinding panic, which of those signs actually saves your life, and which one wastes your final 5 seconds?
That is the ultimate question, isn't it?
It is. If you were out there listening right now, whether you are cramming late into the night, trying to memorize hazard codes for your upcoming ASP exam, or you're a seasoned safety professional walking the floor every day looking to level up your on-the-job expertise, you understand that safety isn't just theory.
No, it's pure practice. It is application.
Exactly. And today is actually a massive milestone for us.
It really feels monumental to reach this point.
Because we are at the grand finale of our Domain 4 series.
The capstone of what's been a pretty intense journey. I mean, we have spent hours tearing through the fundamental chemistry of combustion.
Oh, yeah. And unpacking the complex hydraulic engineering of suppression systems.
Right. And looking into the surprisingly terrifying physics behind combustible dust explosions.
That one kept me up at night. But today, we are landing on a topic that might seem, deceptively simple, almost pedestrian on the surface.
But it is arguably the most vital piece of the entire puzzle.
Our mission for this QHSE Talks is ASP 11 Domain 4 Topic 11, which is select appropriate fire prevention signs and labels.
Just a crucial, essential skill.
Right. Now, I know the immediate reaction some of you might be having. Signs. Labels. Really?
It sounds a bit like an afterthought, honestly.
Yeah, after spending weeks calculating lower explosive limits and designing complex sprinkler arrays, picking out a piece of painted metal seems like, a trip to the local hardware store.
But taking your user interface analogy, because I know you love thinking about buildings as hardware, if a worker crashes a corporate computer system, they get an error message, right?
Right.
They just reboot.
Right, no big deal.
But if they crash a facility safety system because of bad signage, they don't get a second chance.
Yeah, visual communication is really the very last line of defense in a crisis.
Exactly. It serves as this crucial, fragile bridge between all that complex engineering we've talked about and a human being who is likely in a state of absolute prefrontal cortex shutdown panic.
I really do look at it like a user interface. I mean, you can have a state-of-the-art building with the most advanced, flawlessly engineered fire suppression system hidden inside the walls, the ceilings, the floors.
All the bells and whistles.
Yeah. Thermal sensors, high-pressure pumps, exotic extinguishing agents, all primed and ready to deploy. But to the actual human beings working inside that building, all of that engineering is entirely invisible.
It might as well not exist until it goes off.
Exactly. The safety signs and the hazard labels, those are the graphical user interface. You can have a flawless backend, but if the buttons and alerts are confusing or hidden or just visually overwhelming, the user, the worker trying to survive, will crash the system.
What's fascinating here is that a true safety professional doesn't just, open a catalog and buy a sign based on what looks nice in the hallway.
Right, they're engineering a visual environment.
Precisely. And that environment must comply with a strictly regulated, incredibly complex web of standards. We're talking OSHA regulations, ANSI standards, NFPA codes, international ISO directives.
It's a massive ecosystem.
It really is. And choosing the wrong visual cue or placing it at the wrong height or distance isn't just a minor compliance failure.
It's not just a ding on a site audit.
No, it is a fundamental breakdown in that user interface that directly leads to catastrophic losses.
Okay, let's unpack this. Because to engineer that visual environment, we have to understand the DNA of it.
The basic building blocks.
Right. We need to look at the exact colors, the shapes, the precise terminology, and even the calculated physical distances that make up this language of survival. Let's start with the absolute foundation foundation of American safety signage.
The big one.
Yeah, if you've ever looked at a sign in a workplace and noticed a very specific, consistent layout of colors and words, you are looking at the direct influence of the ANSI Z535 series.
To appreciate ANSI Z535, you really have to imagine the absolute chaos of the industrial landscape before it existed.
I can only imagine.
Oh, it was wild. You had factories where one shift manager decided blue meant danger. Another facility down the street used bright green.
And a third just had someone write, watch out for the fire hazard in black marker on a piece of cardboard.
Literally. The American National Standards Institute developed the Z535 series, which OSHA heavily relies upon, by the way, to bring scientific order to that chaos.
So it's basically the definitive rule book.
Exactly. It provides the definitive guidelines for formatting, colors, symbols, and wording to guarantee instant subconscious consistency across the board.
It's just crazy to think that a single sign strapped to a chemical tank has to pass through multiple layers of standardization before it reaches a worker's eyes.
So many layers.
If you are an ASP candidate, you need to understand how this ecosystem interlocks, right?
Yeah.
From Z535.1 all the way down to Z535.6. And instead of just listing them off like a dry textbook, let's trace the actual journey of creating a sign.
I like that approach. The journey starts with the very physics of light, which is covered by Z535.1.
That's the safety color standard, right?
Right. And this standard doesn't casually suggest using, a nice bright red. It scientifically defines the exact chromatic coordinates and reflectance values.
Wait, really? Like down to the actual light wavelength?
Down to the wavelength.
Yeah.
For what we legally call safety red, safety yellow, and so forth. It ensures that the specific wavelength of red on a warning sign printed in a tiny shop in Maine matches the exact wavelength of a sign manufactured in California.
Wow. I guess uniformity at the optical level is essential because human recognition in high-stress environments relies on that instantaneous pattern matching.
Spot on. So we have our chemically precise ink. Next, we have to figure out where this sign is going to live in the physical world.
Right, like if we are bolting it to a facility wall or a structural column.
Or a perimeter fence, yeah.
Yeah.
We're operating then under Z535.2, which governs environmental facility and safety signs.
So that's the heavyweight standard for site-wide visual communication.
Exactly. But what if the hazard isn't the building itself, but the specific piece of machinery the worker is operating?
Ah, like a lathe or a press.
Right, that takes us into Z535.4, product safety signs and labels. These are the warnings affixed directly to tools, equipment, and manufactured goods.
Okay, so that covers the equipment. And no matter if the sign is on the wall or on the machine, you need images that transcend language barriers.
Which brings in Z535.3.
Criteria for safety symbols.
Exactly. This standard governs the creation and testing of the pictograms themselves, ensuring that a drawing of a fire or an explosion is universally understood by anyone looking at it.
Then you have the temporary dynamic hazards, the unexpected spills, the maintenance turnarounds.
Yeah, the day-to-day shifting risks.
Right. And Z535.5 deals with safety tags and barricade tapes.
Think about the lockout-ag-out tags hanging off a crucial pressure valve, or that classic yellow caution tape strung up around a temporary combustible storage area.
Right. And wrapping it all up, you have Z535.6, which ensures that the visual language printed in the heavy equipment manuals matches the physical signs exactly.
And that continuity between the manual and the physical sign is just a brilliant piece of psychological reinforcement.
How so?
Well, when a worker reads the safety protocol in a quiet, well-lit training room, their brain logs the specific shapes and colors.
Oh, I see.
Yeah, so when they see those exact same shapes on the chaotic factory floor, the recall is instantaneous. The brain doesn't have to translate it.
That makes total sense. Now, for our focus today on fire prevention and facility safety, that Z535.2 standard, the facility signs, is the primary battlefield.
Oh, absolutely.
And under this standard, there are 7 distinct categories of signs. This is where we see the incredibly strict correlation between color and the calculated severity of a hazard.
Those categories are danger, warning, caution, notice, safety instructions, fire safety, and directional arrows.
Let's really dig into the big 3 hazard classifications, though. Danger, warning, and caution.
Those 3 represent a highly calibrated hierarchy of risk. They combine 2 distinct variables: the ultimate severity of the potential injury and the statistical probability of it actually occurring.
Right, so at the very top, we have danger.
Yes, danger signs are strictly indicated by safety red.
And a danger sign means you are facing a hazardous situation that, if not avoided, will result in death or serious injury.
And the operative word in the standard there is will.
Well,
It is not a possibility, it is a certainty. It denotes an extreme, immediate hazard.
right, it's totally binary. If you open this specific hatch while the system is pressurized, you will be crushed. If you strike a spark in this specific chemical mixing room, the atmosphere will detonate.
Exactly, it's a guarantee. Then we step down to warning, which utilizes the color orange.
Orange for warning. Got it.
A warning sign indicates a potentially hazardous situation that, if not avoided, could result in death or serious injury.
Okay, so the severity is exactly the same. We are still talking about fatalities and life-altering injuries, but the probability has shifted from will to could.
Right. The hazard is severe, but perhaps requires a specific sequence of events to trigger, or it's just less immediate than a danger scenario.
That makes sense.
Then we step down further to caution, which is dominated by safety yellow. Caution indicates a potentially hazardous situation that, if not avoided, may result in minor or moderate injury.
So you might suffer like a nasty laceration, a first-degree burn, or a sprained ankle, but you are not going to lose a limb or your life.
Precisely. The stakes are lower.
I've always found the notice signs interesting too, the blue ones.
Ah, yes, the blue notice signs.
They stand out to me because you never see that sharp, aggressive exclamation point triangle, the safety alert symbol on them. They feel much lower stakes, right? Like keep area clean or authorized personnel only.
And that's by design. Notice signs are strictly reserved for information and precautions that are completely unrelated to personal injury.
So no bodily harm involved.
Right. They deal with property damage, company policy, security, hygiene. If you violate a notice sign, you might get fired or you might ruin a batch of product, but the hazard itself will not physically hospitalize you.
Oh, wow. So applying the safety alert triangle to a notice sign is actually a violation.
It is a direct violation of the standard.
That distinction is vital for maintaining the integrity of the whole system. Now, knowing the colors and the words is just the starting line, really.
Just scratching the surface.
Because the sources detailed that safety professionals have to balance up to 15 different design parameters when engineering a single sign.
It's exhaustive.
We're talking about the sign classification, the configuration of the panels, the content of the message, the display method, the ambient lighting in the specific hallway.
The intended viewing distance based on worker approach speed.
The material the sign is fabricated from, I mean, it is highly meticulous.
It requires a true systems thinking approach because you are injecting a visual stimulus into an environment that is already overloaded with visual noise.
Right. How do you cut through that?
Well, ANSI relies heavily on a highly recognizable 3-panel layout for most hazard signs to cut through that noise.
Okay, break that down for us.
You have the signal word panel at the top. That's your solid block of red, orange, or yellow containing the word danger, warning, or caution.
The attention grabber.
Exactly. Below, or to the side of that, you have the symbol or pictorial panel, which delivers the immediate graphic representation of the hazard.
The picture.
Right. Finally, you have the word message panel, providing the text that identifies the specific hazard, explains the consequence of interaction, and gives explicit instructions on how to avoid it.
Here's where it gets really interesting, especially for those studying Domain 4. There is a massive, fascinating exception to this 3-panel rule.
Ah, yes. Fire safety signs.
Right. Fire safety signs uniquely do not require a signal word panel at all.
And if we think about the underlying logic of the system, it makes perfect sense. A hazard sign is warning you about something you must actively avoid to stay safe, right?
Right. Stay away.
But fire safety signs, the ones marking a fire extinguisher, a standpipe, or a manual pull station, are doing the exact opposite.
They're calling you toward emergency equipment.
Exactly. The color red is utilized here not to signal danger, but because of the centuries-old ingrained cultural association between red and firefighting equipment.
A sign marking a fire extinguisher doesn't need to scream danger because the extinguisher itself isn't going to kill you.
Well said. So, they typically consist of a bold symbol and a brief identifying word message, bypassing the hazard signal word entirely.
You know, I've actually seen a complete misunderstanding of this in the wild.
Oh, I'm sure you have. It happens all the time.
I was touring a facility once, and they had this massive glowing red danger sign bolted to a door. It looked terrifying.
Let me guess. It wasn't danger at all.
No. You open the door, and it's a mop closet.
A mop closet. Unbelievable.
Yeah. Someone had stored a single gallon of a mild commercial floor cleaner in there and decided they wanted to cover their liability from every possible angle.
That is just classic overcompliance.
But isn't there a massive risk to doing that? Let's call it danger inflation. If a warning and a danger sign both deal with death, how do you stop a cautious manager from just painting the whole factory red?
That is one of the most pervasive, insidious traps in visual safety communication.
Danger inflation.
Yes. Overwarning, or danger inflation, directly triggers a well-documented psychological phenomenon known as habituation, or sign blindness.
Sign blindness.
The human brain is an incredibly efficient filter. If a worker walks down a corridor every single day and passes 10 blaring red danger signs, and their brain learns that 9 of those signs are guarding mop closets or hot water sinks, the brain simply stops registering the color red as a threat.
Just tunes it out.
Completely. The visual stimulus completely loses its neurological impact. It is the boy who cried wolf, codified into a facility's user interface.
Wow. So if everything is treated as a life or death emergency, the user's brain just hits ignore all to save processing power.
Exactly why the discipline of the safety professional is so crucial. If you're out there auditing a site right now, take a walk down a single corridor and just count the red signs.
I bet you'd find a lot of false alarms.
You will likely spot danger inflation within 5 minutes. Your job isn't just to make sure signs exist to satisfy an inspector. Your job is to have the analytical rigor to take those red signs down and replace them with yellow caution signs when the risk profile demands it.
Right. You have to protect the integrity of the word danger.
Absolutely. It must be reserved exclusively for the most extreme, immediate situations so that when it does appear, it triggers an involuntary physiological stop response in the worker.
That requires a deep, uncompromising hazard analysis. You have to truly understand the chemical processes in your facility and the realistic probabilities of disaster.
You really do.
Which provides the perfect transition to our next major area. We spent a lot of time on the signs bolted to the walls, but what about the labels applied directly to the vats, drums, and pipes?
The primary containers.
Yeah, the ones containing the specific chemicals that actually fuel the fires and explosions we're desperately trying to prevent.
Well, in the United States, when we discuss chemical hazard labeling, particularly concerning fire prevention, we are immediately confronted with 2 absolute heavyweights in the industry.
The NFPA 704 system and the HMIG system.
Right. The Hazardous Materials Identification Guide. Both are ubiquitous. If you've ever stepped foot in a boiler room or a loading dock, you've seen them both.
Oh, for sure.
But they were engineered to communicate fundamentally different types of survival information to entirely different audiences.
Let's start with ICON, the National Fire Protection Association's NFTA 704 diamond. Even people completely outside the safety industry recognize this one.
It's iconic.
It's that diamond shape divided into 4 smaller, color-coded diamonds. What is the actual structural anatomy of this symbol?
So the NFPA diamond, formerly known as the National Fire Rating, is a brilliantly compact data delivery system.
Okay.
The left quadrant is always blue, representing the health hazard.
Blue is health, got it.
The top quadrant is always red, representing the fire and flammability hazard. The right quadrant is yellow, denoting reactivity or instability.
And the bottom one?
The bottom quadrant is white, which is reserved for specific, unique hazards. Like a W with a line through it indicating the material is unusually reactive with water, or OX for an oxidizer.
And inside the blue, red, and yellow diamonds, you have a number ranging from 0 to 4, right?
Yes, that 0 to 4 scale is the severity rating, where 0 means essentially no hazard under normal conditions, and 4 means an absolute catastrophic threat.
So a 4 in the red box is bad news.
Very bad news. A 4 in the red flammability box means the substance will rapidly or completely vaporize at normal atmospheric pressure and temperature and will burn readily. Think propane gas.
Gotcha. And a 4 in the blue box?
A 4 in the blue health box means very short exposure could cause death or major residual injury.
But the critical nuance of the NFPA diamond, the thing that trips up a lot of people, I think, is the context of those numbers. The NFPA diamond was originally designed with emergency responders in mind.
Yes, exactly.
It assumes a fire is already happening.
And this raises an important question about audience. The NFPA 704 standard specifically evaluates the hazards of a material under the acute short-term conditions of a fire, a spill, or a similar emergency.
So it's for the worst-case scenario.
Right. When a firefighter arrives at an industrial blaze at 2:00 a.m., they shine their flashlight on the side of a burning storage tank. They don't have time to read a multi-page safety data sheet.
No, they need instant intel.
Exactly. They need to know instantly, will this tank explode if I hit it with a hose? Is the smoke coming off it going to melt my lungs? The diamond gives them that instant tactical data.
Contrast that with the HMIG system, which is geared toward the worker who handles that exact same chemical on a random Tuesday afternoon.
A completely different operational context.
Right. The hazardous materials identification guide abandons the diamond shape entirely and uses a stacked rectangular color bar chart.
But the HMI uses the same core colors: blue for health, red for flammability, yellow for reactivity, and the same 0 to 4 numerical scale.
So the colors and numbers are the same, but the context shifts dramatically.
Yes. The HMI health rating evaluates the day-to-day, acute, and chronic exposure hazards of working with the material under normal operating conditions, not just during a raging fire.
That's a huge difference.
Furthermore, the HMI bar chart includes a fourth, white bar at the bottom, which doesn't list special hazard codes like the diamond, but instead uses a lettering system or specific icons to dictate the exact personal protective equipment required to handle the material safely.
Oh, I love that. So instead of a white diamond telling a firefighter don't use water, the white bar on the HMIG tells a technician wear your splash goggles, heavy gloves, and an apron.
Exactly. It's practical daily guidance. It also utilizes 12 specific icons to visually reinforce that PPE requirement.
You also see right to know, or RTK labels thrown into the mix, which spell out the chemical name, the specific target organs it affects, and its CAS registry number, relying less on abstract codes and more on explicit text.
The RTK labels are fantastic for deep comprehension, provided the worker has the time to read them and the lighting is sufficient.
So what does this all mean for the safety professional? OSHA's Hazard Communication Standard, their HAZCOM standard, mandates that hazardous chemicals must be labeled.
They absolutely must be.
But here is the wild part. OSHA allows immense flexibility. For in-plant transfer containers, the secondary containers workers use to move chemicals around the floor, OSHA does not explicitly force a facility to pick just the NFPA diamond or just the HMI bar chart.
Right, they leave it open.
It is left entirely up to the employer's discretion, provided the chosen system is consistently applied, accurately conveys the hazards, and the workforce is exhaustively trained on it.
And this flexibility, while intended to be helpful, can become a massive liability if poorly managed.
Exactly. Imagine a scenario where a new worker is transferred from Building A to Building B. Building A uses the NFPA diamond. Building B's manager preferred the HMI bar chart.
That's going to cause confusion.
Right. The worker is looking at a diamond 1 minute, reading it in the context of an emergency, and looking at a bar chart the next, trying to decipher PPE codes. Isn't that lack of rigid national standardization for secondary containers a recipe for disaster? How do you manage that cognitive whiplash?
If we connect this back to the core tenets of safety management, the solution is militant, uncompromising internal standardization.
You have to choose one and stick to it.
Exactly. While OSHA gives you the choice nationally, you must eliminate the choice locally. A safety professional must mandate a single visual language for their specific facility and ruthlessly enforce it.
No exceptions.
None. The sources highlight several critical best practices here. For instance, maintaining a robust supply of duplicate pre-printed labels located directly adjacent to the primary chemical stations.
Because if a label gets splashed with a solvent and smears, a worker shouldn't have to guess what it says. Or worse, try to recreate it with a Sharpie and a blank piece of tape.
Precisely. If the duplicate label is 3 feet away, they will replace it immediately.
It's easy.
Right. But if they have to walk half a mile to the safety office to request a new HMEG sticker, they won't do it.
Human nature.
Exactly. The container will remain unlabeled, the hazard becomes invisible, and the user interface of your safety system breaks down. By making compliance the path of least resistance, you prevent the ad hoc, chaotic labeling procedures that lead to catastrophic mixing errors.
We've spent this entire time talking about American systems, ASI, NFPA, HMIG.
Yeah.
But we live in a deeply interconnected, globalized industrial landscape.
Very true.
If you are managing safety for a multinational corporation, or you have an incredibly diverse workforce where English might be a second, third, or fourth language, relying on signs that boldly declare danger or warning in English text creates an unacceptable vulnerability.
A huge blind spot.
Right. We need to shift gears to the international language of safety.
This is where we encounter ISO 3864, the international standard for safety colors and safety signs.
The global standard.
Yes. Specifically, Part 1 deals with workplaces and public areas, and Part 2 deals with product safety labels. The International Organization for Standardization recognized that text-based warnings fail in a global economy.
They just don't work everywhere.
No, they don't. So they engineered a system that strips away language almost entirely, relying on a strict, unyielding grammar of geometric shapes and high-contrast colors.
Let's break down the geometry, because it is fascinating how primal it is. Under ISO, the shape of the sign dictates the fundamental nature of the message before you even process the color or the picture.
The rules are absolute. A circle represents either a strict prohibition or a mandatory action.
So it's an uncompromising command.
Exactly. A triangle is exclusively used for warnings. It signals a hazard you need to be aware of, and a rectangle or square is used for informational or instructional signs, providing guidance or locating equipment.
And then you overlay the color matrix onto those shapes.
Right. Red is used for stop commands or prohibitions. Think of a red circle with a diagonal slash through it.
The classic no sign.
Yeah. Blue is used for mandatory actions. If you see a solid blue circle with a white pictogram of safety glasses, it doesn't mean eye hazard present. It is a direct command, meaning you must wear safety glasses here.
Got it.
Yellow is used within the warning triangles to denote caution or risk of danger, and green, universally, denotes a safe condition, an escape route, or the location of first aid and safety equipment.
This visual grammar integrates perfectly with the GHS, right? The globally harmonized system of classification and labeling of chemicals.
Yes, seamlessly.
GHS utilizes those distinct, red-bordered, diamond-shaped pictograms, like the exploding bomb for explosives, the flame over a circle for oxidizers, or the silhouette of a person with a starburst in their chest for severe health hazards.
And the integration of GHS is a monumental achievement in international safety.
Truly a game changer.
Because a barrel of corrosive solvent shipped from a facility in Germany to a port in Brazil and eventually to a warehouse in Texas will carry the exact same visual warning, the pictogram of the test tubes dripping acid onto a piece of metal in a human hand, regardless of the local language.
So what does this all mean for the worker on the floor? It's essentially universal safety hieroglyphics.
I love that term, universal hieroglyphics.
Right. Whether your native language is English, Spanish, Mandarin, or Arabic, a red circle with a slash triggers the concept of do not do this, and a yellow triangle triggers watch out.
Yes.
But I want to extrapolate on this for a second. Consumers see these symbols all the time on household products, but they rarely understand the deep nuance. Why is an industrial workforce able to internalize this geometric language so effectively?
The difference lies in the foundational concept of a true risk management system.
Huh.
A consumer glances at a label once and throws the bottle into the sink.
Right, they never think about it again.
But a worker operates within a controlled ecosystem, where these symbols are tied to continuous, mandatory training, daily safety briefings, and direct operational procedures.
It's reinforced constantly.
Constantly. The shapes become deeply embedded in their occupational psychology.
And during a fire emergency, the cognitive load on a human being is staggering. The prefrontal cortex, the part of the brain responsible for reading complex English sentences, analyzing probability, and making rational decisions, essentially short circuits.
It shuts down to save energy for the fight-or-flight response.
Exactly. Heart rate spikes, tunnel vision sets in, and the amygdala takes over.
That is the crucial physiological factor. In that state of panic, the brain simply cannot process a paragraph of text explaining how to open an emergency door.
It's just noise at that point.
Right. But geometric shapes and high-contrast colors bypass the complex language processing centers of the brain entirely.
So they go straight to the survival center.
Exactly. The visual cortex recognizes the green rectangle of an exit sign or the red silhouette of a fire extinguisher in fractions of a second, allowing the amygdala to trigger a rapid survival response. The design criteria perfectly match the realities of human neurobiology under extreme stress.
Which brings us to the final, most critical piece of this puzzle. We've talked about abstract hazard concepts, colors, and shapes, but now we need to talk about the literal, physical objects that safety professionals must meticulously label and strategically place throughout a facility to actually save lives when the fire starts.
Exits, alarms, and extinguishers.
Exactly. The physical placement and visual identification of emergency equipment is governed by incredibly rigid mathematics.
Very rigid. Let's start with the most fundamental route to survival, the exit sign.
OSHA standards, specifically 1926.2 which applies heavily here, mandate that an exit sign must have legible red letters, and those letters must be not less than 6 inches high.
And with principal strokes of the letters at least 3/4 of an inch wide, set against a white field.
It's not a suggestion. It's a dimensional requirement. And leading up to those exits, especially in areas where fire is a massive risk, you have specific caution signs.
Right.
For example, in a combustible storage area, a no smoking or open flame sign isn't just a polite request. It must follow the strict color template.
Yellow predominant background, a black upper panel and border with vibrant yellow lettering on that black panel to maximize contrast and legibility in poor lighting.
But if you can't reach the exit, you need to fight the fire. And here is where visual communication becomes highly technical. Fire extinguishers are not universal tools.
Definitely not. Using the wrong extinguisher on a fire won't just fail to put it out, it can cause a lethal explosion.
Therefore, the visual classification symbols on the extinguishers are paramount. Let's run through the 5 main classifications because ASP candidates will definitely be tested on this, and safety pros need to know them by heart. We start with Class A.
Class A fires involve ordinary combustibles. Wood, paper, cloth, trash.
The basic stuff.
Right. The visual symbol for a Class A extinguisher is a green triangle containing the letter A. If you see a green triangle, you know the agent inside, often pressurized water, is safe for a standard trash can fire.
Next is Class B. These are your flammable liquids and gases: oil, grease, gasoline, paint thinner.
The nasty stuff.
Yeah. The symbol here is a red square containing the letter B. You would never use a green triangle water extinguisher on a red square oil fire because the water will flash boil, violently scattering the burning oil across the room.
Exactly, the kind of fatal error the visual interface is designed to prevent. Then we have Class C, which involves live, energized electrical equipment.
The symbol is a blue circle. Right.
A blue circle containing the letter C. The extinguishing agent here must be non-conductive, like carbon dioxide or a dry chemical.
Because if you hit a live electrical panel with a water extinguisher,
the current will travel right up the stream of water and electrocute you. The blue circle tells you the agent won't conduct electricity.
Wow. Okay, so Class D is a terrifying one. Combustible metals like magnesium, titanium, or lithium.
Very scary fires. The symbol is a yellow star containing the letter D.
And these fires burn at incredibly high temperatures.
Oh, massively high. They require specialized dry powder agents to smother them. You can't just throw water on burning magnesium.
Finally, we have Class K, which applies to commercial cooking equipment involving cooking oils and animal fats.
The kitchen fires. The symbol is a black hexagon containing the letter K.
Black hexagon.
Yes. These fires require a wet chemical agent that undergoes a process called saponification, essentially turning the burning grease into a soapy foam that smothers the fire and cools the surface.
Okay, let's recap. Green triangle, red square, blue circle, yellow star, black hexagon. The geometry and color tell you exactly what physics you are about to unleash on the fire.
Beautifully summarized.
But having the right extinguisher is useless if it's in the wrong building. Let's talk about the placement rules. If I have a dedicated flammable storage room, OSHA requires a portable fire extinguisher to be located outside the room, but within 10 feet of the door.
Furthermore, if you are storing Category 1, 2, or 3 flammable liquids outside of a main storage cabinet or room, an extinguisher must be located within 25 feet of the hazard, but absolutely no closer than 10 feet.
See, if I'm auditing a site right now, these distances, 10 feet here, 25 feet there, no closer than 10, seem incredibly pedantic. Why not just mandate that the extinguisher be nearby or easily accessible? Why the strict tape measure approach?
Because these distances aren't arbitrary bureaucratic hurdles. They are calculated based on the brutal physics of radiant heat flux and human biomechanics.
Physics and biomechanics, okay.
Let's look at the no closer than 10 feet rule.
Right.
If a vat of Category 1 flammable liquid ignites, the radiant heat is going to be instantly blistering.
Right.
If the extinguisher is bolted to the wall 2 feet away from the vat, the fire itself will physically block the worker from ever reaching the extinguisher. The hazard envelops the safeguard.
So you need a buffer zone just to survive the approach.
Precisely. But why within 25 feet? That limit is based on the exponential growth curve of a liquid fuel fire and the average sprinting speed of a human being in a state of panic.
Sprinting speed.
Yeah, if the extinguisher is 50 feet away, by the time the worker realizes there's a fire, runs 50 feet to grab the heavy cylinder, pulls the pin, and runs 50 feet back.
The fire is huge.
The fire will have grown so large that the volume of extinguishing agent in a standard portable unit will be mathematically insufficient to suppress it.
The fire literally outgrows the tool in the time it takes to fetch it.
Yes. The 10 to 25-foot window is the precise Goldilocks zone of survival.
It is genuinely mind-blowing when you realize that every number, every color, and every distance in these standards was written in the ashes of past disasters.
It's written in blood, as they say in the industry.
And none of this works in a vacuum. A
Yeah.
beautifully labeled fire extinguisher is useless if it isn't integrated into the facility's overall fire prevention plan, or FPP.
The fire prevention plan is the strategic document that gives all of these tactical signs their purpose.
What goes into that?
Well, a compliant FPP must list all major fire hazards in the facility, detail proper handling and storage procedures, identify potential ignition sources, and describe the specific type of fire protection equipment required to control each major hazard.
It also requires that physical detection and alarm systems be stationed in specific, highly visible labeled locations, right?
Absolutely. You must have a unique alarm signal that cuts through the ambient noise of the factory to alert employees.
So if the visual signs are the user interface, the FPP is the source code running the entire operation.
That is a perfect analogy. And that brings us full circle. As a safety professional, mastering Domain 4, Topic 11 is not about memorizing the difference between orange and yellow so you can pass a multiple-choice test.
It's much deeper than that.
It is about recognizing that a safety sign, a chemical label, or a colored square on a fire extinguisher is a highly engineered safety device. It is just as critical to the survival of your workforce as a pressure relief valve or a deluge sprinkler.
We have covered a massive amount of ground today. We traced the foundational DNA of the ANSI Z535 standard, breaking down the exact meaning of danger, warning, and caution, and exploring the psychological dangers of sign blindness.
We really went through it all.
We debated the specific emergency context of the NFPA 704 diamond versus the day-to-day utility of the HMI bar chart. We explored how ISO and GHS use geometric shapes to bypass language and communicate directly with the amygdala during a crisis.
It's fascinating psychology.
And finally, we unpacked the life-or-death physics behind extinguisher classifications and spatial placement.
It is a dense, intricate topic, but it is the absolute bedrock of practical hazard communication.
To everyone listening, congratulations. If you have followed us through this entire series, you have officially conquered Domain 4 of the ASP blueprint.
Huge accomplishment.
You understand fire prevention and protection from the chemical level all the way to the visual warnings on the wall.
And as we wrap up this domain, I want to leave you with one final thought to mull over regarding the future of this field.
Oh, lay it on us.
We've spent this entire QHSE talks discussing static media. Printed labels, painted colors, metal signs bolted to concrete walls. But consider the rapidly approaching future of the industrial workplace.
Like technology integrations.
Exactly. As we move into the era of augmented reality, smart PPE, and dynamic digital environments, how will the fundamental principles of ANSI and ISO adapt?
Oh, wow.
Imagine a world where a danger sign is no longer a piece of plastic on a machine, but a high-contrast holographic alert projected directly onto your safety glasses the exact millisecond you step into a hazardous zone.
Tailored to your specific language and training level, probably.
Exactly.
Correct.
Will this dynamic, inescapable visual cue make us infinitely safer by eliminating sign blindness? Or will the constant barrage of digital noise finally overwhelm our survival instincts, creating an entirely new kind of technological hazard?
That's why.
It is the next great frontier for safety engineering.
That is an incredible question to ponder as we move forward. Thank you so much for joining us on this massive journey through Domain 4. Keep studying, keep walking the floor, and keep looking out for each other. We will catch you on the next QHSE Talks.